Becca came around the corner this morning and I was like, how you feeling? Not good. Go to school anyway. Okay. I was like, everybody sounds like you. Go to school. All right, so let's take a look. So the function f is defined by f of x equals x squared e to the negative x squared. At what values of x does f have a relative maximum? All right, what we need to do to figure it out? Yeah, we got to do a derivative, okay? It's a product rule. So first times derivative of the second, e to the negative x squared. Derivative of the exponent would be negative 2x, okay? Plus second times derivative of the first. I need to simplify that a little bit. So that's going to give me negative 2x cubed e to the negative x squared plus 2x e to the negative x squared. Did you get that? For your derivative. Make sure I didn't do something wrong. Okay. Now, in order for us to simplify this, we're going to have to find its zeros. So I think I'm going to pull out, I can definitely pull out an e to the negative x squared. Okay. And then I think I can pull out, I'm going to do a negative 2x. All right. So that's going to leave me an x squared minus 1. Yeah. And then I'm going to set it equal to 0. Why do I need to set it equal to 0? For the critical points. Okay. So when we think about the critical points coming out of right there would be plus or minus 1. Okay. But what about this piece? For negative 2x, what would my critical point be? 0. Okay. E to the negative x squared. Okay, so that exponent is negative. It's going to be exponential decay. Is it ever going to reach 0? No. Okay, so those are my critical points. So now, if we think about our chart, I've got negative 1, 0, and 1. So f prime and f. Okay, so if we start plugging things in, all right, and you could even make this x plus 1, x minus 1, but whatever. If I choose negative 2, let's say, okay, in the front, that's going to give me a positive. E to the negative x squared is going to always be what?
Fraction.
Yeah, it's going to always be a fraction, but it should be positive because it's a decreasing, okay? Negative 2 squared minus 1 should give me a positive, so I'm increasing, okay? Between negative 1 and 0, we get like a half, okay? So in the front, I'd get a negative, right? I'd get a positive, and then 1/2 squared minus 1. Negative times a negative is a positive. So we're increasing. All right, let's plug in a positive 1/2. So that gives me a negative, and it gives me another positive. And then if I choose like 2, so it gives me a negative, a positive, so I get a negative. Okay, so in order for us to have a maximum, what does the graph have to do? Yeah, it has to change from increasing to decreasing. So where's my only relative maximum? At positive 1, so it was C on that one. Interesting, okay? That's one where you really have to think, because a lot of times if we get this same sign multiple times, we think maybe we did some math wrong because we're so used to it switching back and forth, but here's one where that did not happen, okay? And it's still doing all the things. Okay, so let's look at our, everything is theoretically impossible until it is done. There you go. Congratulations. Okay, so today we're going to talk about using the candidates test to identify global extrema. Okay, and so we've kind of already done it. I mentioned it briefly the other day when we were doing extreme value theorem. So are you a stock market master? We decided who was the master the other day. Gareth won? Or Salt?
No, it was me.
It was not Jawak. Okay, it was Solomon because he stopped soon. Yeah, he's played it safe.
Fortune favors the bold. That's why I stated.
Fortune favors.
Fortune did not play the way it lasted 10 days. You would have won.
Exactly. Okay. So the number one rule of stock market trading is buy low, sell high. If we knew when those high points and low points occurred, we would be well on our way to making a fortune. Today, we're going to expand on our learning from the stock market game with some more function analysis. All right. So Scott, 5 questions. All right. So I want you to take a second. You can work with the people sitting near you. The value of the stock T days into February is given by, and here's our function. Between 0 and 28. So those are the days. It wants you to find the critical points of, hold on a second. Take a second, work on that.
What's America? God dang it. Sorry, I gotta remind or something from Google Classroom for you that you're in the hard. I'm gonna read your as I grade your test from last week, please remember that I do not give sophistication points and so I really don't want to also encourage you or false participation. If I feel that other spots could possibly get the sophistication point, I'll say so in the feedback. But don't freak out because you won't get a 6. I probably won't get them all done today, so I'll be coming with new threats and stuff. Sorry, I was reading a Google Classroom announcement from one of
Take the derivative
yeah, she's not giving us a sophistication point, but if
right.
she usually doesn't because she doesn't want to encourage
Go
us.
there.
And if she thinks that we did earn it, she'll put it.
What happens if you don't multiply it by points?
And she probably won't be done today for grading. There's no way I got there's no way. Yeah, probably. What's their team? Yeah, or.
Yes.
That's the highest.
That's okay.
That's
Just keep good on the multiple choice. Really, the multiple choice is 1/3. It is true.
I forgot we're doing the entire practice test on Wednesday, I believe, since we're there. Yeah. So. I mean, we have 3 hours, essentially. It's just, if we start immediately. Yeah, I'm trying to factor that.
2 times 90 is 180.
I didn't hear what you said, I'll be honest. You said it and it scared me, so I didn't hear it.
Oh, man. I love Mondays. You all know what Monday reminds me of? The song by Imagine Dragons called Oh My Gosh. 4? That doesn't work. 5. 5 and 18. Negative 5. Negative 13. Negative 5. 36. 36 plus 5 is 41. That works for me. And I think it'll work for the situation. Negative. Negative. Now I gotta find the zeros. And or the critical points. Take 24 out first.
Right. That's how I factored it. It took a minute, but
Yeah, at least I'm not the only one that took a minute.
okay. So you find factors of 180s. You can leave that 0.2 that's already factored out. Just leave it out. Okay. You can just leave it out because we're going to put it in factored form anyway, and 0.2 is not going to equal 0. Like when we're doing like a critical point, so we don't have to worry about that. When I'm factoring that trinomial that's inside of there, I do 2 times 90 to get 180. So I'm finding things that multiply to 180 that add to 41, which is 5 and 36. And then I split that 41 into those two, and then I factored by grouping. Okay, so sometimes I have to do it the long way when it's big numbers that I don't know. Okay, if they're smaller, sometimes I can just guess and check and figure out my parentheses, but for that one I had to actually do some factoring. So then my critical points are at 5/2 and at 18.
So why is it at 0?
Plus,
Do what?
Why is it not at 0?
Because 0.2 doesn't have a t next to it. It's just a coefficient. And so zero product property says you set every factor equal to 0, but 0.2 does not equal 0.
Oh, yeah.
If it was 0.2t, then it would be 0. Okay? Yeah, good question. Sometimes there's so many numbers, it's hard to remember what does what. Okay? All right, so then it asks where does it have the relative maximum? In order to do that one, we have to remember this stock is on a closed interval. Okay, it's from 0 to 28. So when I set this one up, I'm going to start at 0 and I'm going to stop at 28. Okay, so I've got S prime and S. All right, we're not going to go past that 0. So if I put 5/2 in there, and I put 18 in there. So let's figure out our signs. We've got the factored issue up there, so I don't need to go behind 0. So between 0 and 5/2, I might choose 1, okay, and plug it into my derivative. So 2 times 1 minus 5 would be negative. 1 minus 18 would be negative. Negative times a negative is a positive, so it would increase. And then between 5/2 and 18, I might choose like 10. Okay, something a little bit easier. 2 times 10 is 20, so that's going to give me a positive. 20 minus 18 is going to give me a positive. Positive times a positive, so we are still increasing. And then 18 to 28, I might, oh wait, I did that wrong, didn't I? No, I picked 10. 20 to, oh sorry, that's a negative right there. Okay, yeah, that'd be a negative. Sorry, I was doing my math. Then we might pick 20 between 18 and 28. So 40 minus 5, 20 minus 18, positive and positive. So we increase, okay? So where's it going to have a relative maximum? Okay, relative max at 5/2. Okay, then it says, what is the value of the stock at that instant? What would I do?
Just plug into the original.
Plug it into the original function. So we would do S at 5/2. We definitely want to use a calculator for that. Okay, and we get 251.458. We're talking about money, so they probably wouldn't use that third decimal place, but everything we do in AP Cal, we do 3 decimals. Okay. And then likely exactly the same on number 3, where would we have a relative minimum at 18, because we go from decreasing to increasing. So we'd have a relative min at t equal to 18. And then if we want the value of the stock at that instant, we'd do S at 18, which would give me $3.20. Okay. All right. So now the question about that. That's what we already done. Okay, we're talking about those relative mins and maxes. Okay. But now what's the absolute highest value attained by the stock during the month of February? How do we know? So we know where the relative max is. We know where the relative min is. Okay, this is a closed interval. It's a continuous function. So what are some other options for where these things could occur? At the endpoints. Okay, so we need to look at the endpoints as well. Okay, so let's look at S at 0 and S at 28. Okay, the endpoints are a possibility. Okay, so if we plug those in, S at 0 is $230. S at 28 is $446.533. Okay, so we've looked at our critical points. We've looked at our endpoints. So what is the absolute highest value that the stock attains? Yeah, it happens at S at 28. It's $446. Okay, this is our absolute maximum. Okay, the reason we know that's true is because the only place, all right, that maximums occur are at critical points or endpoints. All right, and we'd already looked at the critical points. We knew what they were there, and they were not as high as it is right here. Okay, and then what's the absolute lowest value attained? Yeah, that one came from the day before, right? That one came from day 18. It was $3.20. So S at 18, which was $3.20. That is my absolute min. Okay, so when we use the candidates test, it tells me that we want to consider the endpoints and the critical points. So half t, S of t. All right, we put the endpoints and the critical points. And we look at all their values. The largest value is the absolute max. The smallest value is the absolute min. Okay, and notice where we plug it back into. The only thing we use the derivative for is to find the critical points. Okay, but our values come from the actual function. Okay, so we would look at all of these y values. Highest is absolute max. Lowest is absolute min. Okay, and we could find our relative max and mins within there because of what we know about the behavior of the function in terms of increasing, decreasing, and so forth. The candidates test will for sure show up in a free response. So everything we're going to look at example-wise are free response based. Okay, today we're going to do one that's actually from the 2018 exam.
For problems like that, would we be allowed to use a calculator?
It depends. Sometimes yes, sometimes no. If it's an easy function, it'll be no. So it can show up both places. Yeah, good question. Good question. A lot of times it's in the calculator section.
Yeah, well, maybe no.
Maybe we'll get lucky.
Yeah, maybe.
Okay, I don't know what the calc test looked like last year because I didn't have a group to take it. But the year before it was probably one of the easiest calc tests they'd done in a long time. So my guess is they probably went back a little farther last time. So maybe we're more in the middle, which would be nice. They kind of trend. You can kind of watch them trend, which is kind of cool. Okay, but I do have access to the free response from last year, just not the multiple choice. Okay. All right, so just some heads up for you. This is just a direct correlation to the extreme value theorem. The thing to remember that your candidates are the endpoints and the critical points. Okay, so that's the biggest thing. When we use a candidates test looking for absolute maximum, and you're going to know when we look at a problem because it's going to phrase it in a way when you know, hey, I'm going to use the candidates test to do this. And then the thing you're going to look at are those endpoints and the critical points. And here are your 3 steps. Find the critical points, list the critical points and the endpoints in a table, and then evaluate the function at all those points selected. Okay, so the calculus is in knowing how to do it and finding the critical points. The rest of it is just algebra, evaluating, all right, and drawing conclusions. Yep, he agreed. Big brain energy next door. Okay. That's so good. Green apple cotton candy. It is my absolute favoriteest right now. All right, so here's one from the 2018 AP exam. All right, the AP exam, it was question 5. Okay. So it says, let f be the function defined by f of x equals e to the x cosine x. Find the absolute minimum value of f on the interval from 0 to 2 pi and justify your answer. Okay. Now, the nice thing is the candidates test, that chart is justification. All right. The sign chart is not, but the candidates test chart is. Okay. So notice they gave me a closed interval. All right. So that's one hint that we want to use the candidates test. And they said absolute. Okay, so that's a hint that we would want to use the candidates test. So that being said, step 1, find your critical points. So let's do that. And notice this is part C of probably 4 parts. Okay, so f prime at x. You want to try that derivative? Okay, go. So this one's a little bit tough. We got some trig we got to remember in here, trig equations. It's been a hot minute, right? Okay, so let's take a look. You're going to have to do the product rule, right? Because you've got e to the x times cosine. So first, derivative of the second, derivative of cosine is negative sine, plus cosine times derivative of the first e to the x, okay? Really the only thing we can factor out there is an e to the x. Would you agree?
Yes.
Okay, so e to the x times, and if you're okay with it, I'm going to do cosine minus sine. I just reversed them because I don't like that negative in the front. It makes me feel weird. Okay, so now we're going to set it equal to 0, right? Does e to the x ever equal 0? No. Okay, so I don't really have to worry about that piece. Okay, what I have to worry about is this. Cosine minus sine equal to 0. Okay, now we got to think about that a little bit because it's a trig function, a trig equation that we're trying to solve. There's no identity that we can use to, rewrite one in terms of the other, but what about this? What if I move it over? And I think about, remember, we're going from 0 to 2 pi, so 1 revolution around the unit circle. Where is cosine equal to sine? Okay, it's the pi over 4s, okay? Has to be a pi over 4. It has to be pi over 4. Anywhere else where they'd be the same? And 5 pi over 4. They'd both be negative in the third quadrant, remember, because the x and the y are the same at those places, okay? That's what it's asking me. Where is x equal to y on the unit circle? Okay, so it has to be the over 4s. So my critical points, so we get over here to my candidates. All right, we've got x and we've got f of x. We know we're going to test our endpoints, which were what? 0 and 2 pi. We're also going to test pi over 4 and 5 pi over 4. Okay. Now, this is question, bless you, this is question 5, which means this is a non-calculator question. Okay. 1 and 2 are calculator, 3 through 6 are not. Okay. So to answer your question, Jawak, this is a non-calculator question. All right. Now, don't be too, I think we're going to be okay. All right, I think we're going to be okay. Because let's go up here and we're going to plug it into the original function. Okay, so I'm going to have e to the 0 times the cosine at 0. Well, what's e to the 0? 1, and the cosine at 0. 1, and so I get 1. Okay, as my y value. I'm just plugging it into the equation. This is f at 0. Right? Then we're going to do f at pi over 4. Now, e to the pi over 4, I have no idea what that number is, okay? Times the cosine at pi over 4. Okay, well, what's the cosine at pi over 4? Square root of 2 over 2 e to the pi over 4. Okay. All right, no clue what that number is, but it's positive. All right, which means it has to be more than likely it's greater than 1. Why do you think it's greater than 1? E to the x grows, right? It grows. So we know it's got to be bigger than 1. All right, let's do f at 5 pi over 4. Okay, so again, e to the 5 pi over 4, that's a pretty big positive number. And then the cosine at 5 pi over 4. Negative square root of 2 over 2. E to the 5 pi over 4. Well, a positive and a negative gives me a negative. So right now, that's my lowest value. I don't know what it is, but it's lower than the two positive numbers. Okay? And now let's do f at 2 pi. Okay? So e to the 2 pi times the cosine at 2 pi. All right, and what does that leave me? E to the 2 pi. Okay. All right, so now, question-wise, okay, who's our absolute minimum?
Probably the negative one.
It happens at the negative one. It's the only negative one. Okay? Probably the negative. That's a good probably, all right? That's a good assumption. Okay? we would go right here, we would box it in, and we would say this is our absolute minimum. Now, the good news is this chart counts as your justification. Okay, it counts as your justification. You've labeled it as absolute minimum. Notice it's the y value, not the x. The x just tells me where it happens. Here is how this part was worth 3 points. Okay, the first point was that you did this right here. You set that derivative equal to 0. That was 1 point. Okay. The second point came from identifying that these were 2 of your candidates, including, besides the endpoints. They're going to assume you know to test the endpoints, okay? And then the last one is your answer. So it was worth 3 points, okay? So that seems like a lot of points to me out of 9, all right? Seems like a lot of points to me. But they're giving you credit for taking the derivative accurately and setting it equal to 0. They're giving you a point for finding those critical point values. So even if you couldn't figure out the last part, you've still got 2/3 of the points for that part. Does that make sense? Keep your pencil moving. God bless it. My phone is blowing up. Okay. All right. That was that one. What do you think? Candidates test. All right. Let's look at another one. I think this one's kind of fun. It says the rate at which Sarah's AP daily videos generate likes is modeled by the function L, where L of T is measured in thousands of likes per day, and T is measured in days. Since the videos were first posted, and T is between 0 and 35, so she's been doing it for 35 days. The derivative of L of T is given by the function L prime of T equals sine of pi T over 30. At what time between 0 and 35 is L of T a minimum? Justify your answer. Okay, now this one's a little different, all right, because they didn't give me the actual function, all right? They went ahead and gave me the derivative. So can I use the candidates test on this one? Not really, okay? I've got to have the function to be able to use the candidates test. So this is where we're going to go back to our sign chart and talk about what's it doing, increasing, decreasing, all those kinds of things, okay? So the first thing we need to do to find my critical points is to set that derivative equal to 0. So I'm going to take the sine of pi T over 30 and set it equal to 0, okay? Now, this one, oh, my back is killing me today, y'all. This one's a little bit trickier, all right? Because we got to think about where is sine equal to 0? Anybody know? 0 pi, 2 pi, okay? So, let's find that first one. Okay, so if we're looking where sine is equal to 0, we're talking about where is the inside stuff equal to 0. What value would T have to be for it to equal pi? It'd have to be 30, okay? T would have to equal 30, all right? Is there any reason for me to try 2 pi or anything else? No, because T is between 0 and 35. Okay, so when we think about our sign chart, we got 0, we got L prime, and we got L. Okay, we know nothing about L, but we're going to figure out what it's doing around it, okay, around these critical points. So a critical point that I could pick between 0 and 30, y'all, I'm probably going to pick like 15. Why do you think I might pick 15? It's 1/2 a pi. That's why. It's something I know. Okay. So if I pick T equal to 15, all right, that's the sine of 15T over 30, or the sine pi, of pi over 2. Okay. What's the sine at pi over 2? Positive or negative? It's 1. It's positive. Oh my gosh, so increasing. Gosh,
Get me out of here.
you had to come up here and sit with me.
Yeah, I'm perfectly healthy.
That's fine, right now.
Okay. And then if we pick one between 30 and 35, think about the unit circle. Okay, think about the unit circle. If I do, let's say, the sine of 32 pi over 30, that's the sine of, 16 pi over 15? Okay, would that be greater than pi or less than pi? Greater, so which quadrant would it land in? The third quadrant, which would make my y-coordinate what? Negative. Okay, so a lot of thinking right there. That's the hardest part of this question. Okay? All right. So it's asking me for, where is L of t a maximum? Notice it didn't say absolute, it just said a maximum. Okay, so let's look at it. If I go from increasing to decreasing right there, that's definitely going to be a max. All right? But this time we've got to think about the endpoints to make sure that we don't have some kind of max or at those points. All right? So if we look at the first one, it says I have an endpoint and then I increase. So would that be a max or a min at that endpoint?
Min.
It'd be a min. Okay. I have an endpoint. Okay, so I've increased, then I've decreased, and then I'm going to decrease down to this endpoint. Do I have a max or a min? I have a min. It's like y'all want to say mid right there, but you didn't. All right, so now if we write our justification, so at t equals 30 days, L of t is a max because, okay, what they gave me was the derivative, so that's what I have to talk about. L prime at 30 is equal to 0, so we identified it as a critical point. And it changes from positive to negative. So that's your justification. Right? Likely you would get a point for the critical point at 30, and then probably for your justification. That's probably 2 points for that part. All right, last one. Question about that, what we're doing, it's just kind of what we've been doing, just a little more application based.
When are we gonna, do the thing where you take the derivative factors? I mean, like.
When we get back from Christmas. Yeah, we have like 2 more sections to do after we get back, maybe 3 for Unit 5, and then we'll start integral calculus. That's fun. Okay, antiderivatives. I like going backwards. But we got to be good. We're sure we're good at going forward before we start trying to back it up. You will be. Okay, anyway. Sorry. I want to make a dance to that one, but I hadn't done it yet.
Is this a double maximum? Double maximum?
Okay. So let's take a look at this one. Okay.
I'm just a little hesitant.
All right, so be careful here. It says the graph of y equals g prime of x, the derivative of a function g, is shown above for x's between 0 and 5. At what value of x does g have its absolute minimum? All right, justify your answer. Now, what makes this one hard is what kind of graph are we looking at? A derivative graph. We're looking at a derivative graph, okay? So critical points occur where g prime is equal to 0 or g prime does not exist, okay? So looking at the graph, okay, does this derivative ever equal 0? None, okay? Does this derivative have a discontinuity in it where it fails to exist? No. Okay, there's no holes, there's no asymptote. Okay, so our only options for an absolute minimum come from where? The endpoints. Okay, so my endpoints are the only candidates.
I thought I didn't exist at the corner or whatever.
Okay, but differentiability. Okay, but this is the derivative, so don't care about that on this one. Okay, if the derivative failed to exist, there would be a discontinuity of some kind. Okay, there'd be a discontinuity of some kind. Okay, now think about this. If we think about the sign chart from 0 to 5, we've got G prime and G. What can you tell me about this entire derivative in terms of its sign? It's always positive, so it's always increasing. Okay, so where does your absolute minimum have to be? At x equals 0. Okay, because it starts at that endpoint, then it increases forever. All right, so the absolute minimum, okay, occurs at x equals 0 because G prime at x is greater than 0, meaning it increases on the interval from 0 to 5. Therefore, G of x increases on that interval. He agrees. I'm so glad we got a hype man next door. It will. It will. Only one more Monday, y'all. I know. We got it. We got it. We got it. I made sausage balls last night, gluten-free. Shut the front door. They were so good. Becca took them to her theater party, but they were really good. I made them with that Red Lobster gluten-free Cheddar Bay biscuit mix.
OMG, that sounds so good.
You put the it's that garlicky, buttery stuff on the top that makes them so good. Okay. All right, question. That's the candidates test. It's really what we've already done. You just have to consider the endpoints. Okay. It was a good day to miss, Laura. I'm sorry you're sick. All right, so your lesson practice is your worksheet 5.5. Now, don't laugh at me, but I copied and pasted this, and I didn't feel like renumbering it. It's 9 through the second 11.
The second one.
Okay, not the 7th 11, but the second 11. Okay, so 9 through the second 11. All right, so I didn't feel like retyping and doing it all, so it is what it is. Okay, go ahead if you want to click on your link in Google Classroom and do your wrap up. Let's get that done. Okay, so remember tomorrow quiz 5, 1 through 4. If you've not done any of that practice, now would be a good time to kind of do that. Okay, because if things were to run over tomorrow, I mean, the quiz is a little bit longer because it covers more sections. Okay, so I want to be sure that we've got plenty of time. So quiz 5.4 tomorrow, and we won't start class until 9:50. Actually 9:57, but okay, so we'll go 9:57 to 11:28. Then you'll go straight to third block. Okay, so things you can do today. All right, you can work on any of this practice. If you want to do your second round of test corrections, we can spread out a little bit in here. I've got a few calculators, so we may have to rotate who does what when, or if you've got your own, and that's what we're doing. Okay, in a little bit, I'm going to go and check on how we're progressing with all the stuff. And since it's 9:45, we'll take a potty break here in just a second. Okay, we'll all go.